And we are happy to have this collaboration with the Edgerton Center of Massachusetts Institute of Technology and with the Physics Department of Ferrara's University and National Institute of Nuclear Physics of Ferrara branch. With us is working our very important laboratory technicians, Gianpaolo Milani. Obviously, we are supported by our principal, Roberto Giovannetti, his staff, and some other colleagues. But first of all, who is inspiring us? Is here with us. An ocean apart. The most important person who is inspiring us is today here with us and is Ed Moriarty from Edgerton Center of MIT. Uppsala. Which are the aims of the project? We are trying to give the students the possibility to follow their curiosity, to improve their motivation, to know the importance of the collaboration between people to achieve the goal, to make themselves self-employed and in the construction of their knowledge, and especially something that is unusual in the school, to make mistakes that help them to learn new skills. We are using during the project a new methodology. It's not a traditional methodology of teaching and learning. It's more a student-centered blending methodology, a mix of the learning by doing, project-based learning, collaborative learning, near-peace-based learning. First of all, is an active learning. So they are learning and they are learn to learn by themselves. But this is a project, we used to say, of the students, by the students and for the students. And this is why we'd like to ask them to talk about it. I'll leave the floor to Lorenzo.
Thank you. Hello, everyone. I'm Lorenzo, and I'm representing the Sprocky team. Last year, my group and I worked on creating a smart speaker that is a device capable of producing a certain type of music depending on the weather outside, the time of the day, and the temperature. Our project consists of a box made out of wood in which we put a battery, an amplifier, 2 speakers, and a little touchscreen to control it. This speaker works thanks to our Raspberry Pi that we program with a software that can collect data from a weather system and play a specific kind of music depending on the weather, so if it rains or not, the time, and the temperature. By now, we have made 4 main playlists of about 15 songs, and the genres are euphoric, happy, relaxing, and sad. Actually, our final target was to create an artificial intelligence device that could be able to recognize if the song was sad or happy without having to make a playlist beforehand. But unfortunately, we haven't done that. We divided an entire day in a 6-time slot based on the hours. Each slot has 3 possible temperatures written in degrees, a cold one, a warm one, and a harsh one. Then we have to see if it rains or not. For example, if it's 3 p.m. and it's 0 degrees and it doesn't rain, the speaker will play calm music or chill music. Okay, now I'm going to show you a short video of our speaker working. Well, that was our project. And now I will leave the word to Luca that will present you another project.
Hi, thank you, Lorenzo. My name is Luca, and I'm a member of Team Ocho. Today, I will introduce you to our project. We've built a special pair of glasses to facilitate the everyday routine of blind people. We started with just one ultrasonic sensor to detect obstacles, but now we are using two ultrasonic sensors connected with a buzz and a servo motor to spin them and allow it to cover a large area. In this way, we are able to collect more details than before with fixed sensor. We initially designed the glasses with pen and paper, using the measurements of a pair of glasses from one of our mates. Then we built the first comfortable prototype to see what it would like. We then designed the glasses on Shape, a 3D printer program, and printed them. Unfortunately, we had a problem. They were too small and fragile. So we redesigned the glasses and printed the two templates afterwards, and then set them up later. We have also tried to make the extractor as light and comfortable as possible. We have a box to place the Arduino and the power supply. It was more difficult. Then we weren't sure in which position the box would be more comfortable. One of the possibilities we are considering now is behind the head with a bench. We are continuing to work on it because we want our project to help the people, and the experience that we are having is amazing. Having a common aim and typing to achieve the with other mates achieve both. Now I present you a short video of the project. Now I leave the word to Luca.
Hi everyone, my name is also Luca, and among the many projects we are working on in this year, there is one called Iron Fist. Our idea was to build a magnetic glove that could lift iron and other metallic objects. For example, it can be used to separate iron objects in a group of different objects, or it can be used to ease the opening of a heavy door. At first, we built an empty solenoid without any iron nucleus, but the test didn't go as we expected. In fact, we couldn't lift that much iron, only a few grams. Thanks to that, we started to understand the law behind the magnetic field. The prototypes has been significantly improved using an iron nucleus and a thicker copper wire that increase the magnetic field and that allow us to lift a greater quantity of iron. After that, we have intervened in order to guarantee stability to the whole coil, attaching it to the glove an elastic band. We are now trying to discover the best solution in terms of electricity in order to make everything work. In particular, we have created a circuit attaching the coil to 4 Li-ion 3.7 volts batteries connected in series, adding also an on-off switch and a potentiometer to control the overheating of our coil. Now I will show you a little video about our project.
Vai. Spegni.
Sta scaldando un po'. So that's it. Thank you so much for your attention. I'd like to give the word to Ilaria.
Hi, I'm Ilaria, and I'm going to talk about some projects of the past years. The first one I would like to talk about is the music glove. The idea was to create an unusual instrument that you could play only by moving your hand. It has been created starting from an old glove. A sensor that measures flexion has been sewed on each finger and then connected to an Arduino. Then, thanks to a specific program, you can play songs and choose among different sounds, as if you were playing the piano, the violin, or the guitar. One of the beautiful sides of this project is that it can also be used to help rehabilitation. And now I'll show you a short video about the project.
Poi basta, non ce
The next project is called Magnetic Express. This group wanted to create a model of a magnetic levitation train. So first of all, the team built a structure that can levitate above a special track because of magnets. Then, since they wanted the train to work thanks to nothing but magnetic fields, they built a couple of electromagnets, then connected them to an Arduino, and finally placed them on the train. The idea was that, by switching on and off the electromagnets at a specific time, they could repulse some other magnets situated in the middle of the track, and therefore make the train move. And after many tries, the group managed to make the project work. The last project I would like to talk about is called Water Rocket. As the name implies, the goal was to build a rocket that can reach a certain height using air pressure and water. But not only. In fact, the team wanted to make the rocket land slowly, thanks to a parachute, so that in this way it can be reused, and also collect data about the environment and the atmosphere with some electronic devices. This project, like the Magnetic Express, is still in progress, and at the moment it can fly up to 20 to 25 meters, but it will probably reach greater heights in the future. And now I'll leave the word to Marta.
Hi everyone, I'm Marta. Now I'm going to talk about 4 small projects we did. Beside the long-term project that were, carried out during the school year, there were some short-term activities done on occasions like presentation to middle school students or as an introduction to the program. These activities were also important because of the wow factor. In fact, experiments that seem simple to us as school students might look like magic to younger students. On that note, Einstein famously said that if you can explain it simply, you don't understand it well enough. So the real purpose of these activities was not only to outreach to younger students through peer education, but for us to go for a simpler and more effective approach to education. The first of these experiments was the tonograph, an electronic device that can produce musical sound. This basic design is the foundation of a synthesizer used in electronic music. By building it, we learn prototyping and how a circuit can produce an output to drive a speaker. It's the project we use capacitor, resistors, and potentiometers. The capacitor is an electronic component that has the ability to store electrostatic energy associated with an electrostatic field. So in our circuit, it has helped us to keep the charge and energy accumulated to infinity. Now I'm going to show you a short video about this project.
Basta la farina vedo preziosi. Ma è uguale. Hai visto quella comune? Oh mamma mia. Di solito lo dico.
The second experiment was the tensegrity table. It consists of a table that was always in equilibrium, even if the top and the bottom pieces of the table were connected with small fabric or plastic strings. This is because the tensegrity is the ability of a structure to balance, so to ensure stability, through the simultaneous presence of both tensile and compression efforts. We also did a challenge on this project, where everyone made a video with the process of construction of our tensegrity table, and then we had to show how many things it could support. The tables had different shapes, from a normal coffee table a dozen centimeters high, up to a table 1.5 meters high, or in the shape of a spaceship. The last experiment I'm going to speak about is aurora beer, which consists of a light total reflection in plexiglass. This project was shown to the lower class students and made by us. It consists of a simple circuit of some colored LEDs powered up by a 9-volt battery, encased inside a wooden structure with a plexiglass figurine on it. What happened was the light struck in the figurine at such an angle that it will get totally reflected inside it, making a very cool aurora beer. Each of us drew our own plexiglass figurine on shape with many different images, like Avengers cartoon and comic characters, and even animals and much more. Now I let Alicia speak.
Hi everyone, I am Alice and I will talk about how this project works. So every year we start around October when Professor Edgerton comes to Ferrara with a couple of other MIT mentors to help us with the first phase of the project. Usually we first show the students that might be interested in joining some project from the previous year and tell them how we work, giving them a presentation not too different from what we are doing now. Then we usually give them a first taste of the hands-on approach by setting them easy tasks to achieve in a short time in random groups so they can also start knowing each other. In the next meeting, we start collecting everyone's ideas about what would be interesting to do. These initial ideas can range from very narrow and specific projects to just broad files that could be interesting to investigate. Then we split these ideas into 4 or 5 main topics that People can choose what they like best and can start getting into smaller groups to discuss more specific project ideas. Once we have come up with the main themes and ideas that appeal to the students the most, we start reducing them by having the students voting their most favorite until we end up with the desired number of projects. Now I'll leave the floor to Irene.
Hi everyone, I'm Irene, and at this point it's time to form the teams. The students are free to go to the team associated with the project they are more interested in. We also strongly encourage to have a balanced number between males and females. In the team, as an average, people of different genders tend to approach problems in different ways, both of which are very valuable and complementary to the other. Each team is then assigned a mentor, that is a student who has already participated in the hands-on physics project in the previous year, who will follow and help the team during the meetings in the role of a player coach. The main role of the mentor is to ensure that their students enjoy the time spent in the program at maximum, having fun while learning and creating. The mentors will guide the students through the process of designing the project, of researching the theory behind it and the technological use, of prototyping and then finally building. The best mentor is not the one who knows all the answers to all the questions and is not his job to answer them, but the best mentor is the one who can stimulate his students the most, be passionate about their project, so that they really take it to heart and enjoy every little step achieved while striving for their goal. A key skill that the students will learn through the program is how to deal with failure. There has never been a project where everything worked perfectly from the first trial. Learning how to deal with failure is particularly important because it makes the person capable of remaining lucid when things fall off, of understanding both what worked and what there is to improve, and of never giving up, but instead to try hard next time. In the first 2 meetings, the team will define exactly the specification of the project they want to build, and they will be doing research about it. After this period, the teams will also start making the first prototypes while still going on with research and designs. This is a very important step, as if at this point that the students will get a real sense of what their project will look like and what has to be improved in their designs. Thank you, and I will leave the word to Riccardo.
Hi everyone, my name is Riccardo. By the last week of January, the teams have usually done 3 to 5 prototypes of their projects. In that period of time, we usually hold a week-long intensive workshop where students remain at school every afternoon instead of just one. And a team of instructors and college students from MIT and Boston area, with Ed Moriarty as a leader, comes to our school to help bringing experience, knowledge, and materials. By the end of that week, the teams are often able to complete a working model of their project, similar to what the final version will look like. Sometimes on weekends we organize an open house event at our school to share our project with parents, friends, and the rest of the community, followed by a similar event at the Department of Physics at the University of Ferrara for teachers, professors, and alumni. It's important for us to share our projects becoming teachers between teachers. The program then continues with weekly meetings until the end of April in order not to distract the students from their finals. The open house event we do are very important for us as they help spreading awareness to our local community of what's going on at Roiti, at our school. Some collaboration we have now started right thanks to this event. An example of it's one that happened with the physiotherapy department of our university. And because of this collaboration, we also had contact with the rehabilitation center of our city and with the Spalding Rehabilitation Center of Boston. At least twice a year, we also send groups of students for a day to the middle schools in our city, where they present some projects to kids there and have them build some little ones in order to introduce them to the STEAM world. Last years, because of COVID-19, it was a bit different. For first, unfortunately, college students from MIT still helped us with important suggestions when we had problems, but of course they were on Zoom calls with us. Speaking of our organization, during the pandemic, we continued the hands-on physics project also during the red zone. For about a month, we couldn't go to school and work on our projects directly. Despite that, we decided to continue to meet each other on Zoom. We tried to have some doing different workshops online, like the Aurora Beers, hologram pyramids, rocket with banking soda, and clouds in bottles. These were some kind projects that we did in several 2-hour Zoom meetings to spend a few time together and learning something different. And now I will have the word to Daniela.
Hi everyone, I'm Daniele and I'm going to talk about EDW. EDW is an engineering and design program held in Boston every summer. And in this workshop, participants have the opportunity to design and build a project with the help of various mentors, and our high school participated in 4 editions of this amazing project. During the summer of 2019, a group of students have been sent to Boston, to MIT itself, to take part in the edition of EDW organized by the Edgerton Center. This is a program that lasts 5 weeks, where around 30 students from the Boston area and from various parts of the world cooperate to create different projects chosen by them. And they have time to work on their program until the final presentation, when they'll share their work with their family, friends, and the community. In the summer of 2020, due to COVID-19, the Edgerton Center decided to organize the annual remote engineering design workshop, thus giving the opportunity for more international students to participate in the initiative. In fact, 14 students in total from Hope decided to participate in the summer school, together with other students from the collaborating school in Barcelona and other American students. The students decided to work on a single common project with the aim of bringing a piece of our beautiful but small city to this international program. The final decision was, therefore, to create a model of the SK2021, which spectators could play with it, changing the color of the light in the moat, between the drawbridges and controlling the fonts, all through some position sensors located on the outer side of the walls. Thanks to the help of MIT mentors and our UNIFE colleagues, everything was fine. At the end of the 2 weeks, there was a big Zoom call together with all the participating nations, where each team presented the project. To this day, the castle appeared in the local newspaper twice and is now exposed in one of the main halls of our school, where students are still playing and having fun with it. Now I'm going to show you a video of this castle.
Ascolta, se noi alimentiamo Arduino dalla 12 in Arduino.
Ok, allontana.
Allontanati? Sì. Vai. Però dobbiamo togliere la parte qua dietro.
However, this year everything was a lot different, starting with the location, Roiti School. The students were 27 in total and decided to split into 3 different groups, the Nerfinator, the Windmill, and the Savo. There were 2 main ideas behind this project: to build something environmentally friendly and to build something more interactive just for fun. The working days ended around 5 p.m. with an ending meeting to share the ideas and to update each team and head in a video call. The white mill is a scale model of a water mill that demonstrates the functioning of a real one, creating electricity from a flow of water running on a wheel connected to a dynamo. On the other hand, the Nerfinator is a mobile turret that can move via RC and that can shoot foam bullets, aiming with the help of a Wi-Fi camera. All the turret was also made to look like it was from the world of Phineas and Ferb, a cartoon when there was an hand-sculpted scale statue of Dr. Doofenshmirtz. Last but not least, Il Savo. Il Savo is a scale model that resembles a famous statue in Ferrara of Girolamo Savonarola, and that can follow the sun with the help of solar panels to produce electricity. The statue was hand-sculpted by the students. Now I'm going to show you a small video about these three projects. Here we have the wag mill in a function with the water running on the wheel. Here there was the first test of the Nerfinator going around our gym. And here there is the Savo with his solar panels on the end. Those 2 weeks have definitely been very intense and difficult for our students, but they allowed the students to get involved, to get to know each other better, and to have fun together. And to have an unforgettable experience that certainly made them grow and learn from each other. Now I leave the word to
Hello everyone, I'm Allegra, and this has been my first year at Hands-on Physics project. And I would like to talk about the differences between the teaching method here in Italy and the method that we use at Hands-on Physics experience. The main difference is the relationship that students have with their teachers. In fact, in Italy, we feel that professors are not our friends, and we often feel judged and criticized for everything we do and we say, and we tend to feel in awe of them, and sometimes we have the fear that everything we say is wrong. The first thing I noticed when I joined Hands-on Physics experience is how free I was to express myself and talk about any idea that I had in my mind, however bizarre it was. The first times it has been really strange to talk to professors from another country and that I've never seen in my life in a friendly way. And instead of telling me that I haven't studied or I haven't listened, when I was wrong, they helped me to understand the reasons of my mistakes, and then I learned. In fact, at Hands-on Physics program, you get wrong, you learn, you grow and mature. Italian school system is more focused on theory, but I can memorize all the physical laws of the world and still don't remember anything. In Hands-on Physics experience, they show you physics, they make you think and create a project as you build it, and you integrate the various theory concepts by learning how they work in the real world. In my opinion, this approach is more efficient because by studying only on a book, you get bored, you lose concentration, and you can't use all your skills. And when you do an exercise, you just need to know how to apply the right formula at the right time. But when you build a project, you have to think about it more, do a lot of tests until you find the one that works. I think that with this method, you are also able to put yourself in the game better, also because by working in a team, everyone is able to bring up their talents. Perhaps the Italian school method, like in Italy, we have to work harder to be able to pass the test. And this lets us to study and work more, and therefore remember things better. But I do not think that studying for a fear of getting a bad grade or also for the fear of the teacher
is a right thing. I think we should have fun while we study, and we would also be more likely to do it. Not always the good grade is the result we want. We tend to take good grades for the parents or to be able to have credits and future possibilities. But in my opinion, the result that is really satisfying is seeing our project finished after all the hard work and effort, because you know that it doesn't matter what grade you have in math, you have managed to create something, understand how it works, and that something will remain. Thank you for the attention, and now I will leave the word to Liz.
Thank you, Ale. Hi everyone, I'm Liz, and this was my first year taking part in the HOPE program. First of all, I'd say that I'm very proud of being part of it, because it is so much in both sides of human interaction and learning process. Even now, in this moment of closure because of the pandemic. Actually, I joined the project mainly because of that. Because when I saw so many people enjoying spending time together at school, doing some strange but fun and interesting activities, and being comfortable expressing themselves during it, I thought, okay, for sure, I don't want to miss this. I'm not gonna lie, at first it's been a little bit difficult to communicate, because even if I am a really confident person around people in general, I was insecure about my ideas because of a lack of self-confidence. Every time that eventually an idea came up in my mind, I was scared introducing it because I thought it was useless, because the other ideas to me were creative and fun. But now that I think about it, everything has changed in a little amount of time, thanks to the safe environment that I found, the new friends that I met, and the team that has formed around that project ideas. This experience gives us the opportunity to get out our comfort zone, to make new brand experience in new context. And I think it really helps coming out of the shell, exploring new fields, and being conscious about our potential by learning from mistakes, like a lot of mistakes, and with curiosity and with the help of the students that have been in your shoes before. Said that, I'll leave the floor to Ricky. Thanks for your attention.
And finally, as a conclusion of this talk, we would like to thank all people who support us, who are listed on here on the slide. Thank you very much for your attention, and if you have some question, go on.
Congratulations on putting together a beautiful presentation, folks. Number one. This seemed like it was a pretty good team effort as well.
Thank you for that.
And Ricky, have you been working on your English? Because you just were really, really good just now.
Thank you.
And I'm kind of curious, in this project, there's a lot of time where you are having to communicate in English. I mean, everybody. And I'm kind of curious, you didn't speak about that dimension of the project, just exposure to using another language and working with the other language, not just learning the language, but having to think in the other language. I'm curious, does that slow things down a lot, or does it, talk about the problems and the advantages of that? It could be anyone.
Yeah, for me, it's more difficult than in Italian language, or my bad English. But I think that if you don't try, you don't know if you can do it.
Mm-hmm. Well, I can tell you that I've known you for a couple of years now, and it's incredible how much you've learned. And I'm not sure if it seems that way to you, but to me, it's amazing. And your English is way better than my Italian. Way better. So, what about with working with the MIT mentors and whatnot? Do you find that you're able? I mean, I know it's difficult in general, but with the other students, all the students in the program, do they see it as an opportunity to get more fluent in English in particular? Do they see that as an advantage, or is that just a pain?
Yeah, sometimes it's difficult talk with MIT mentors, but because they use specific scientific words, so that we don't know, so it's difficult. But I think it's really cool having someone from another country that you can speak with. So, and it's really helpful having someone that knows English to talk with.
Hello, Jörg.
Hi, greetings. I didn't want to interrupt you because I really liked your talk, and thank you very much that you have been here, or are you here at our Students' Congress. And I totally agree that your English is quite good. So, and I really think it's much better than Ed's Italian, and even better than my Italian.
Or my German.
Yeah, you know the word Glockenspiel, so yeah, but very
I'm
nice,
curious.
very nice talk. So I really hope that anytime in the near future we manage to have some projects together, and that we probably can visit you in Italy with some students, and probably you can visit us here too, because I really enjoyed your visit here at our Student Congress 2 years ago. I think that was the last one we could do in presence. So probably in the future we'll continue this type of collaboration.
Amen. So I'm kind of curious about the presentation itself. What do you see as the value of putting together this kind of presentation? I know it's a lot of work. How does it compare to the building of the projects themselves? Do you see this as being its own project, making a presentation to communicate this stuff? And what's the value of that? Not just for communicating it to me or other people, but for you about understanding your own project. Do you see that it helps you put what you've learned in perspective for yourself?
I think that it really works, and that because that's where it brings.
Lean into the microphone more.
Okay, sorry. We all have to communicate to the other, and do you hear me?
Yes.
We all have to communicate with the other and find ourselves and to build this text and the presentation itself, the slides and so on. And I think it was really engaging, really beautiful, and also the community was good, was a really good thing.
Well, I noticed that you recorded this. Am I right? Is it recorded?
Yes, it's recorded.
Wonderful, wonderful. Because I hope I'll be able to get a copy of this. There's some professors and administrators at MIT that, and my students that are going to see this. I think it was a beautiful presentation. It really showed kind of the passion for it, and showed how you, it's not just about the individual projects. The fact that the students were so involved in organizing and running and mentoring in this is itself, I think, that one of the most magical aspects of what you're doing. And you guys should be incredibly proud of what you've done. And I think there are going to be some companies and universities and whatnot that are going to be really happy to have you join them going into the future. So congratulations on a really wonderful presentation.
I want to foster what Ed said. I really liked your presentation. I really liked also some of the Spanish students did as a presentation, a video. So which I have the idea that we can do a kind of video context here at the SFN, that student groups can make videos about their projects and reach these videos in, and we have a bunch of videos we can select from and make a small competition on the project and the videos. So I think that would be also a great idea to work internationally, because you can share videos easily, and afterwards we can come in contact about these videos. And that, I think that would be a great idea. And I really liked your presentation. I really hope too that the recording went well, because lately we had some difficulties with the recordings, mostly that the presentation and the audio was okay, but the video feed was like behind that the creator was get only one picture per minute or so. So let's hope that this didn't happen here, but mostly or in any case the presentations and the audio feeds are okay, and I think that's the more important part. And of course, it would be nice to have you also on the video seeing switching places. I think that was also very fun to see how you switched your places. Thank you.
Thank you.
Thank you.
Hey, LA and Bonde, do you miss it, or is it really nice to be able to know that you don't have to do it?
I think they're writing because they cannot speak and they don't have a mic.
They're speechless.
They wrote that they miss it. I think you can read it in the chat.
Oh, yeah, yeah. Well, I'll tell you, this was a wonderful presentation to wake up to. And thank you for putting it later in the day. It was much better than the 5 o'clock ones, Jorg.
Thanks, Ed, for joining us.
Yeah. Okay, and Jorg, whoops. I am. Yeah, I just finished the presentation. I'll be down in a few.
Jorg, are you there?
Oh.
I'm here.
Oh, I'm sorry.
Okay.
I didn't know you guys were still on.
Ed is still talking. I thought we could listen to his phone call, so.
Thanks, Jorg, for inviting us.
I thought you ended the presentation because the screen went away when the phone call came in.
Christina,
I'm driving my wife to work.
Christina, thank you very much that you've been here. It's always a pleasure, and it's a great contribution to our Congress. And I really hope that more people were watching, but it's quite strange this year. We have some of the talks are watched by 80, 90, 100 people, and some talks are only watched by only 1 or 2. So it's a great difference, or great spread between the audience. So not so sure. We also have rooms here where or talks. There's the audience can join physically, but it's not so well accepted by the students and the teachers. I don't know why. I'm a little bit disappointed because we have put a much effort in that people can join physically and come here and watch the presentations or some of the talks in presence. And yeah, a lot of these talks are without the audience. Instead, it might be possible that these people could be watched directly. So, but let's hope that it's getting better and better next month and next year. So I really look forward and hope that in the next year we can have this whole Congress totally in presence, but we also will continue to broadcast it online, because I think that's a very good possibility to spread the word and to show these fantastic presentations to not only people being here at the SFN, but also everywhere else. During the Congress, this concept worked out quite well. We have a lot of schools attending from other places here in Hessen. So I think that's this Congress might become a national thing, or even a more widespread event, and not only a regional event here in Kassel.
Well, tell you, Jörg, I would love to get a chance to talk with you and maybe get a few people together about what worked and what didn't work and why, because again, we're in a new world, and how to design for it is really interesting. This has been a fabulous, I mean, for me, it's been a great experience, okay, just so you can get that feedback. But I understand it's really hard, especially when you're mixing in presence and not, and different aspects of what you can do in each case, and the different communities that you're trying to bring together, et cetera. It's a really interesting design problem.
Yeah,
so, and,
I can tell you, yes.
And there are some projects going on right now that, like the music glove, there's also an MIT student that's created a glove that you guys are going to love to see. That's a virtual reality glove, and he has it linked into a VR world. And we have the team in Barcelona right now that's got a robotic hand, and we're going to link them together. And Jörg, it'd be kind of fun to get some of your students involved in these kind of projects that link together nicely. So I'd like to talk with you once you wake up after doing all this stuff.
Yeah, after I went in coma.
Yeah. Okay. So are you guys just drop me a line when it's appropriate to you, and I try to answer you and on WhatsApp when I will be available. Not today, not tomorrow, but afterwards. I think we'll find some time. Okay. Well, good job, everybody.
Okay, guys, thank you very much. I'm going to close the channel now.
Ciao.
Bye-bye.
Bye. Bye. Ciao. Arrivederci. Ciao.
Arrivederci.